It's wonderful to be here. So I'm Poppy Crum, and congratulations on the awards that you have been recognized for and the work you've been recognized for. It's really phenomenal. I wanted to, in this breakout session, I'm hoping we'll have an active dialogue, but I wanted to give a sort of quick background on who I am, but not who I am from my bio and the things I've done, but more the problems that have driven me and why. Because if you look at just a few things about me, I was a violinist. Okay, I was a concert violinist who was also an engineer, who became a neuroscientist, and then from being a primate neurophysiologist, went into the entertainment industry, and from the entertainment industry went into the construction industry, and then came back to the medical industry. All of that for me makes complete sense, which maybe it does, maybe it doesn't, but I feel like I'm still working on the same problems. And I'm still trying to tackle the problems that throughout that entire thread have been about how do we understand and build technology that helps people be more effective and succeed in the problems they need to solve in their lives. And for me, those problems have hit at different places, and I've been able to dive into them and see opportunities to build technology that's going to help solve those problems at each step. And that's sort of driven the common thread. So there's sort of three different threads that have been key to sort of how I think about the world. And I think where the technology-human relationship is so important to be assuring that technology doesn't become the arbiter of how we succeed, but instead technology empowers us. And that's where we want to be. So bear with me for a moment. I like to use examples of what I mean. All right, so closing the loop, decoding and optimizing internal experience. Maybe some of you have seen this demonstration. This is when I built a version of it I built up. If you take a look at the sunlight up in the corner, right? You should, I think if you're watching it, you see the bubbles, they move up the screen, and they may seem to sort of go up and appear to float off the screen. Is everyone seeing that? Like if your eyes are directed at the sunlight, the bubbles probably seem to be going up at a trajectory. Okay. But if you shift your gaze to the bubbles, suddenly you realize that there's, the bubbles are moving straight up, and there's this conflict between black rectangle on right side. Yes, I know I can't move it. I'll try to move it off. But there's a conflict between the local and global motion of the bubbles. Okay. And you have this sort of vertical grading that's in conflict with you have the horizontal grading that's in conflict with the vertical grading. And dependent on whether the bubbles fall in your foveal vision or in your periphery, your brain resolves that information differently. When you're looking straight at the bubbles, your brain weights the information in ways that you experience sort of vertical trajectory of the bubbles. And when you're looking up at the sunlight, your brain weights the information in different ways, and different for each of us, that you experience the bubbles to appear to go off into the side, because you're getting a weighted combination of the two different local and global motion. Now, the reason I like this example is it gets at a really important part of what has to happen with technology and any human experience, is that something as simple as this illusion, points to a really profound part of how we experience the world, which is fundamentally that at any moment in time, something as simple as where our eyes are directed completely changes the experience of physical information in the world, right? And if we're trying to build technology, or we're trying to assure people have successful experiences, we start to realize that we have to have input about the internal state of the user, albeit in this case, a very simple input, such as where my gaze is directed, suddenly gives me a lot of insight about the internal experience someone might be having. But it also tells me how heterogeneous someone else's experience might be without that knowledge of closing the loop. Now, another example might, which then got me to a lot of the problems I'm trying to solve, which if I look at something as simple as the most dynamic and intelligent thermostat on the market today, it learns so much information about me. It saves me resources, it saves me time, it saves me money, but it doesn't know the most important thing about my success, which is whether I'm hot or cold, or whether I've been successful at any moment in time. Effectively, I am a dynamic time series that needs to change at each of these moments. I need to be able to close that loop. And at the simplest thing, knowing how to extract the signals of an individual in that dynamic time series to make an effective to enable technology to become intelligent, to be successful, is a really important problem that we haven't fully solved yet. So this device is learning things about me, but it might be optimizing for the wrong goals, right? Is it 2 p.m. and I'm trying to train? Is it 2 a.m. and I'm trying to be cognitively effective at a different part of my circadian rhythm? Where is my body state that makes me effective? Am I a petite woman? Am I a large man? Every one of these moments in time and different personalizations means this device should be interacting with me in a different way. Now, so I call that empathetic technology. It's really the idea that, we, coming from the bubbles to this, we need dynamic optimization and longitudinal data that is taking in the context of the environment and the body to be able to assure that our technology is supporting and empowering people in the right ways. Even something, so in my history, I started as a psychophysicist and experimentalist, became a physiologist, I've worked on lots of different species, but at the same time trying to solve these types of problems, which is how does the brain weight and decode information to form the perceptual experiences that we act on? And what do the neural circuits look like? But then, at some point when I was research faculty in the med school at Johns Hopkins, I'd just gotten my funding, and I recognized that all of the things we're theorizing and building out here that are going to be a lot of the dynamic probabilistic nature of how the brain works was going to be able to be supported on semiconductor chips in our consumer products to help optimize how we live. And that made me want to move into the technology industries where we could start building these technologies, but from a perspective that incorporated how dynamic the brain is, how contextually driven it is. My autonomic nervous system drives my pupil to dilate when my brain's having to work harder. Now, we use those types of tools to understand objectively the internal experience of the system, and they've lived in labs. We all know now these types of dynamic changes say a lot about the state of our body. They say a lot about how, diagnostics for certain pathologies, but they also tell us a lot about the personalized context of the user and the success they're having in an environment. When our brain is having to work harder, we know that dynamic optimization, that contextual change is such a critical part of our future tools, because just the diameter and pupillometry that we can pull off of a signature like from our eye becomes something that's ubiquitous in all of our technology. So we start closing the loop in so many ways. I've used a lot of different methods to be able to understand user context, be it breath and chemistry of the breath, to understanding the different dynamics of our bodies and how they radiate our emotions and show up in different ways that we can use all as just effectively toolboxes to help us untangle and understand how technology can be reactive to the state of the individual to help empower them. Now, this is sort of leading up. So the three things that I was getting at is, one, understanding context is key. Understanding how we measure and aggregate data about the user so that we can assure our technology is interacting with them as effectively as possible. But then it comes down to a really important thing, which is how do we customize and personalize information? Because the state of the individual is always driven by the exposures, their priors, the contextual dynamics that they've been exposed to shapes how our brain optimizes its resources. I worked with marmosets for a very long time, and marmosets are unique in some ways. They're extremely social. It's critical to allowing them to thrive in different environments. And it's also an interesting thing because they are native to the Amazon. They're native to the Amazon, and they are very social, but they live in dense foliage, which puts a constraint on their system in a way that's very unique to, some other New World monkeys, but it may be thrive in dense foliage, but not all. Macaques are very different. They have very rich visual representations of how they share emotion and communicate. But marmosets can't, because they can't see each other. And, because of all the leaves. And it's caused them to develop very rich vocalizations that, transfer and communicate information. But they also have very strong pheromonal systems, such that the dominant female secretes pheromones that, it impacts the, through her social status, the biology of all the other females in her social group. You end up with these very dynamic, rich ways of communicating when you have a constrained system, or you have context that impacts how successful someone will be. And the more we understand individuals' context, and that's part of the dynamic relationship that we build into our technology optimizations, it opens up so many things. So here's a problem, a simple illusion that drove a lot of my early work when I was trying to decode the brain in different ways. I want you to just, if you can hear, tell me if everyone can hear this. You should hear a sentence.
The state governors met with their respective legislatures convening in the capital city.
Did everyone hear it? Yeah.
The state governors met with their respective legislatures convening in the capital city.
It's a pretty benign sentence, but the important thing here is, I think everyone heard a cough, and you heard the state governors met with the respective legislatures convening in the capital city. Well, of course, the trick is there's no S, yet our brains, fill it in, right? So now here's what's actually here.
The state governors met with their respective legislatures convening in the capital city.
And in that case, there's no...
The state governors met with their respective legislatures convening in the capital city.
Now here, listen one more time.
The state governors met with their respective legislatures.
Okay, let me go back one and take in and play. Here we go. Now listen one more time. What's been inserted is a cough.
The state governors met with their respective legislatures convening in the capital city. The state governors met with their respective legislatures convening in the capital city.
So hopefully you experienced probably something similar to me, but not exactly, which dependent on your native language and your priors and expectations, it's going to shape what your brain does with ambiguity, right? And so this is this situation where there's missing information, but I've stimulated the physiological system with an ambiguous stimulus, which is in this case a cough, but a broadband sound. That broadband sound is going to get shaped by my brain in different ways, but it's going to be based on probabilistically what is most likely to have filled that in. And understanding the context of how we deal with ambiguity, how we deal with information. This particular example may seem, arcane, but in fact, this is what happens to all of us in noisy environments. It's what our brains are constantly having to do as we experience different aspects of hearing loss. But hearing loss can be introduced by our context, by the nature of the environments that we live in, right? The dynamic, our hearing thresholds and how we hear is, you can predict what city someone lives in because of the context and nature of the sounds that surround them, which starts influencing their biology. So you have to be caring about how our brains are going to be shaped in a very individual way by the nature of their information. So let me then sort of lead to the last, so how we close the loop to understand objectively internal information of the user to optimize our technology and experiences so that technology is not an arbiter, but we can empower everyone. And what might be shaping those internal experiences, those internal optimizations of people so that what do we need to care about? Those are two big questions. And then the third one was like how unique our bodies are, our brains are, and how do we leverage technology and identify the places where technology has been an arbiter of success that we need to break down and now start building new technologies that help empower people. So those have been key aspects of what I've been focused on. And in this case, I just want to give a last example before we get into discussion, which is, I coming from, being at Johns Hopkins and being very much focused as a neurophysiologist in the technology space, when I was at Dolby, one of the biggest realizations was that technology was made in one-size-fits-all solutions in places where it had a huge impact on what people experienced. And rarely did we ask the right questions to understand the impact it was having to people. An example is you may have even recently heard with Apple AirPods that it's taking customization of the body, of the morphology of someone's head. In order to create experiences that have successful immersive experiences, spatial content, which can have impact on any augmented reality experience or the success of how somewhat effective someone might be in communication, you have to have a map, a filter of effectively the morphology, how sound interacts with someone's head and torso, the convolutions of their pinna and ear, in a way that creates a very bespoke filter of amplification and attenuation. And up until really the last year, it's always been a one-size-fits-all European white male that's been used pretty much as the representation of the human body. And you would put someone in an anechoic chamber, or you would put a dummy, a sort of a model of head in something like this, and measure the impact of the body on how it is sound transferred to the inner ear. And that seemed like a reasonable solution for people for many years, but in fact, it isn't. And we are all very unique. And when you look at the impact of how people experience something like that, this is, a bird's eye, that was a bird's eye view looking down, where this would be the nose in this polar arrangement. And this is where people should be experiencing sound. They're all hearing the exact same things coming out of the exact same system. And these are just 4 different users of different demographics. And you realize that people hear things in their head. They have what's called front-back reversals, where things that should be in front of them are perceived behind them. You have things that are collapsed. You have things that are not localized in pinpoint, but instead are very diffuse. It creates this heterogeneity that means that whatever technology is being implemented has no control over how a user is going to actually experience it, which then means that technology can't help individuals and can't be a partner in helping someone be successful in their environment. And to do that, we've been able to solve this problem computationally through computer vision and through many different types of imaging methods and neural nets. And it's a very tractable problem today because of other technology advances, which has been very successful. My teams did this, built this. You've seen teams now at Apple also do this. The beauty here that I think is important is it also led to changes and solving bigger problems beyond how do I customize and personalize to optimize my experience. Because in recognizing that the brain is incredibly how we experience the location of a sound, the brain is interpreting fine relationships between specific frequencies. You also have to realize that then it's not just about the shaping of this special function that we call, a head-related transfer function. We also have to understand the physiological system and the unique properties of hearing capability, someone's hearing thresholds that are the first input to that system, or effectively the second input, and the translation. And that meant that you actually have to personalize information for how somebody hears and their hearing capabilities. But historically, you could not, because there was no way to customize hearing thresholds for over-the-counter devices, for hearing aids, for things that are for hearing what we would call at the time personal sound amplification, right? We each have our own filter from our body, but we each have our own filter with regard to the process to the state of our cochlea and the hair cells in our cochlea and their immediate state. That led me to spend a lot of time then focused on the Over-the-Counter Hearing Aid Act and how we translate standards and derive effective ways for technology to be measured and be successful, so that we don't end up with markets and places where technology is, the behavior of technology to a user and a consumer is not predictable. The goal was, how do we build technology for all domains, meaning even entertainment industry and communication industry, that enable someone to have the best experience? But to solve that, we actually had to go in and really focus on the opportunities for innovation and getting the over-the-counter hearing aid act passed, so that it became a capability for people to customize their hearing. And I worked on that. I actually wrote a lot of the standard that went into driving the over-the-counter hearing aid act, because effectively you have to understand you've got devices that behave in so many different ways, and you've got to be able to extract what's a lemon versus what's a Lamborghini, and have objective ways of assessing technology. So I've spent a lot of my time in standards. I believe in them very strongly. If you can't objectively describe the performance of a technology and the tolerances for what is good enough, it will never scale, and it also won't be interoperable with other systems. So by writing effective standards, it became a critical part of helping drive the Over-the-Counter Hearing Aid Act, because then we would have metrics for consumer devices that could be tracked and measured and accepted by the FDA. These sorts of approaches to solving problems really help drive markets and become a critical part of how we think about the success of technologies that are moving in different spaces, where we want to be bridging the consumer capabilities of technology with the actual impact they can have to longevity and success of an individual. And they have to be transparent. So I'm just going to end with this. This was something I worked on that is just came to fruition really in the last month or so, maybe about 6 weeks, where the FDA has moved forward. But the idea that you personalize and customize your hearing through devices, and that even that you monitor it and think about an over-the-counter access, went a very different way in the 70s compared to how we see. Over-the-counter eyeglasses were supported in 78, whereas evaluations requirements were instituted for hearing aids in the 70s as well. So they went opposite directions. And, the story tells itself, because, as circa 2015, less than 10% of people who could benefit from hearing technologies actually had access to them. The cost was really high. It was driving markets there was a huge amount of need, and devices that no devices that could support things, but also because there were devices that could, but they couldn't be sold, they couldn't be marketed, they couldn't be tracked, they couldn't be assured for their performance. And the joining between the consumer groups, the medical groups, and really having a strategic approach with the FDA and working with them led to great success in really driving and bringing forward great reform that's going to help a lot of individuals. And I think when things happen in those spaces, I think we're in this space now where there's a lot of opportunity for standards reform. And I'm going to stop right there and leave it at that. So thank you. But summarizing, we have to know what people are experiencing. Number one, we have to figure out more ways to seamlessly understand that information. And we have to have longitudinal data that allows us to do that. For me right now, I'm focused on the ear. I'm focused on the capabilities of the ear, because it is the one place where neural data can be tracked longitudinally, and in ways that people will wear the devices long term, and not just at short epochs where you measure, but instead something that you actually build up an effective time series of the individual. So, okay, great.